Okay, well, why don't we get started? First, I want to welcome everybody once again to another networking channel event. We've got a great program today. Today, we're going to be talking about network data sets, what exists and what are the problems, what are the challenges. And Christophe, Diot, and I, you can see both of us and the panelists hopefully pinned in the video here. We're going to MC the event today. Let me just say a word about Christophe and myself, since we're the organizers of this. So if you've tuned into previous networking channel events, you may remember that in September of 2021, Christophe had a great event that was sort of organized about Google's networking infrastructure, which was really a great networking event. Christophe helped co-found Sprint's Internet Technology Lab, which is in the Bay Area, which has a strong emphasis on network measurement and network data. He was the founder and director of Thomson's Paris Research Lab, chief scientist at Technicolor, CTO at Saffron Analytics, and for the last 3 or so years, Christophe has been the network analytics technical lead at Google Global Networking. And Christophe was also one of the co-founders of the ACN's Internet Measurement Conference back in, must have been 2001, something around that, maybe 20 years ago, and been active in that. My name's Jim Kurose. I'm a professor at the University of Massachusetts. I've been here for my career and also spent some time at the National Science Foundation leading the computer science directorate there, computer and information science and engineering directorate. And I've also been involved in IMC as a program chair and steering committee member here. So, Christophe, you want to say a little bit just about what today's program is going to look like?
You're doing a great job, Jim.
Okay, well, I can keep going. All right. Well, so today we're going to be talking about network data sets. And, you know, I think we're all here because we understand the importance and the value of network data sets. And today's networking channel events got two parts. The first part, well, you know, when the panelists and Christophe and I were starting to organize this, we were looking around saying, okay, well, you know, network data sets are important. What's a good site that we could point folks to? And we looked around, and it's sort of hard to find sort of a repository of pointers, for example, to public data sets. So we started to put one together. We want to share that with you, get folks' input on that. But the first part's going to be about public data sets, not just data sets, but also tools for analyzing and working with data sets and test beds for actually generating measurements. And this will be relatively short. We've got a shared Google Doc that's open. Anybody is going to be able to edit this, and we'll ask folks to edit it. And then the second part of today's session is about challenges and future directions. So that's where we're headed today. I don't want to add anything to that, Christophe, or was that just like perfect?
As usual, perfect.
All right. Well, before we get started, just a couple of reminders then. This event is being recorded. You should have seen that when you signed on. When we post these on the networking channel website, and actually we generally get more views after the fact than people who are participating. So the videos are actually viewed by a lot of people after the fact. We're going to encourage, as always, questions and discussions. There are a couple of ways that you can do that. There's the chat here, and there's also the bottom right-hand side of your Zoom screen. There's a question and answer menu button there. And so you can post in either of those places. And then finally, the conversation is going to continue, as always, on the Slack channel. Okay, and we'll post some information about the Slack channel as soon as I turn my video off here. Okay, so before we get started, I want to introduce the panelists that we have here. They'll be participating in both of the two halves of the event here. So just in alphabetical order, you see their pictures there on the slide, and hopefully you'll see them in your video as well. Dave Clark from MIT, Italo Cunha from the Federal University of Minas Gerais in Brazil, Timur Friedman from the Sorbonne in Paris, Phillipa Gill from Google in the USA, and Sue Moon. So Sue, you get probably, you get the Heroes Award. It's 1 a.m. in Korea, Sue. So thank you for participating in a global event where the time zone's late for you. So thanks again. Thanks again to all the panelists for not just being here, but for all the prep work that we've done and the things that we've done ahead of time here. Okay, so I should have put this slide up earlier. We're recording questions and answers in the chat. And again, here's the information about Zoom. I'll cut and paste it into the chat window as soon as we get going. But the conversations often continue on quite lively in a SLICOM Slack subchannel on the networking channel, and you see the URLs there. And again, I'll cut and paste those in just a second. Okay, so let me take these slides down. Stop sharing my screen for a second. Okay, so we're all back, and now I can see you, Sue. Hi. Okay, so let's move into the first part of the event here. And what we want to do here is show everybody a document that we as the panelists and organizers have been putting together, which is a list of sites of data sets that we've used as researchers, that we know other people have used, and it's not meant to be complete, right? As a matter of fact, what we'd love for people to do is to start adding their commentary to the document and sites as well. So if somebody can cut and paste the URL for the document into chat, I'm going to actually share my screen in just a second. Okay, I've got it right there. I'm going to share my screen and just show you what we as a group have sort of put together. Okay, so I see a number of people are. And then as we started to refine it, broke it down into some different categories. So there are data set collections. And so you see, some of our, maybe I shouldn't say favorites, but they probably are. Many of them are our favorites and many of them that we've used. So CADA, Crawdad, MLab, RIPE, Switch, Ant data sets, Dioptra. That's one I haven't seen yet, but somebody added that recently. The Impact Cyber Trust related to security, the peering database, route views, AppNic. And then also, I wanted to get to the last bullet at the end, and we're not going to go through these individually, but both IMC and PAM, which are probably two of the major conferences in internet measurement and data, have awards that are associated with papers and presentations that provide open data sets. So I'll just say thanks and congratulations to both of those groups for both of those conferences for actually doing that. So we have the data sets themselves. One of the things that we realized as we started to put that together is that in addition to data sets, there are tools for working with them. So you see a list of tools there. And then we have test beds also where you can take measurements, make your own measurements on it. You can potentially, make them publicly available as well. So maybe I'll stop talking myself and ask the panelists, do you have favorites here? Do you have other things that we still want to be adding here? And then maybe we'll look to the community and everybody else who's online here to, if you want to add things to the chat or add things actually into the document. I see people starting to edit already. So again, any comments from our panelists first about this?
I guess I was thinking about this morning, and it's not necessarily a specific data set, but a style of data set. So things like RIPE Atlas, where you have a platform where people can make their own measurements, but they also make it very easy to share the outputs of your measurements. And Measurement Lab similarly is collecting data for one purpose, but all of the trace routes and other data is made available. And analyzing BGP hijacks over the years, having these sorts of maybe seemingly useless bits of data kicking around that you can go back to and say, hey, like, do we happen to have a trace route that covers that path? Like, having these things made available for later unexpected analysis, I think is something that's really valuable.
Yeah. Okay. Maybe one question I'd ask you right away, Phillipa, is if you had a question of, gee, do we have a trace route of X, or do I have, data element Y? How would you actually find that?
Yeah, I mean, it's good we have this doc to put it all together. I mean, it's sort of like, domain knowledge. So knowing to look for, knowing that RIPE has their trace routes, MLab has theirs, KAIST has theirs, kind of knowing that these kind of pockets of data are around that you can look at.
I know that, am I muted? No.
Nope, we can hear you.
Yeah. I mean, you've scrolled past the top of this list, but KAIST has a huge number of data sets out there. You can go look at some of those URLs. They're currently, you asked specifically about trace routes. They're currently trying to build a new tool for access to all of their trace route data. They hope to have it up and running by sometime in the summer. They were slowed down by a bunch of issues, some of which were COVID related, but it's a project called Fantail, and they're hoping to have that up in a few months, and it's supposed to give you access to all of the trace route data they have. So that would be a place you could go make a query.
Okay, great. Let me remind everybody, if you're not speaking, could you mute your microphone? And then remember to turn it on when you do speak.
Jim, I want to make a point. I mean, my experience with data is that you start with an idea and you take the data set that's available, and then you start finding things that you expect or don't expect, and then you want more data of the same type. And I think that's what the problem is. That's where ecosystems like KAIST are better, because they provide you huge set of data sets in the same area. And for me, that's always the problem. Okay, when we started at Spring, we decided to collect packet headers, and then we realized that, oh shit, we need BGP, and then oh shit, we need ISIS, and so on and so on. So when you're Sprint, you can go and get your data. It's easy, but when you're academic, it's very difficult to connect an ecosystem or to get multiple data describing the same thing. And that's basically what's happening when you work with data. I mean, that's my experience.
Right, but there's also the question about the retrospective aspect of it. So Phillipa said, oh, we could go back and find something, and maybe it wasn't measured specifically. It wasn't measured back then because somebody knew Phillipa wanted to use it 3 years later. So there's value also in the series of data that's being gathered if people want to look back and do things that are retrospective, right? So it's not always just, oh, now I want to take measurements, but it's got that retrospective aspect also.
I think, go ahead. The MLab folks recently had a town hall about what to do with their multipath traceroute data, and whether they should maybe discontinue that data set because, well, most people are interested in single path trace routes. And the upshot of that discussion was that, well, having these years and years of retrospective data, even if nobody has used them now, who knows, in the future, they might really want to see that. And it's a unique resource. And I believe they've decided to continue with that.
Mm-hmm. Italo, did you have your hand up before? Sorry if I missed it.
I was just going to mention that when we're looking for trace routes, I had a comment on the tooling that we have to handle the data can definitely be improved. So carrying trace routes is one thing that I wanted to do, like in many different projects. And it seems like KAIST might be coming up with something for that later on. And BGP Stream is one example where the tooling definitely made handling the data easier. So gathering a lot of data, we should also think about how to handle it easier as we go forward.
Mhm.
One of the issues in this space is a funding issue. And the community's been discussing this from time to time. The question is, how do you sustain these longitudinal data collection activities and who pays for them? If you are a typical academic, you get funding from NSF in a 3-year cycle. And Jim, I'm not trying to dump on NSF here. I know you fought the good fight, but when you go in and you say, well, I want to keep doing the same old thing, the merit review committee say, we want new, we want different, we want transformative, we want innovation. You're doing the same old thing. And sometimes the important thing is to keep doing the same thing.
Right.
And I certainly know that's an issue for CAIST that's constantly being forced, to put it bluntly, to take the same old thing and make it look new so that they can get new money to do it, even though what they're really trying to do is this, in some cases, I mean, you look at route views and it goes back to what, 1997 or something like that. It's actually quite bothersome to take somebody that's been doing something like that, like route views since whenever they started, and say, by the way, you have to make it look new. And so, no, I'm doing the same thing because that's what the community needs. And that has come up. I thought I'd mention in this context that I'll put it in the chat that NSF actually asked some of us to run 2 workshops on barriers to collecting internet data. They were called WAMBIR. And the final report from WAMBIR, I'll put the pointer to it in the chat, talked a lot about this, the problem of sustaining longitudinal collection and the problem of curation and storage and so forth. So there's some serious challenges here that do arise because of the reality of the funding constraints.
Yeah, so nothing personal taken, Dave, and I have said exactly what you've said before myself. You know, I will say my sense is that in the last 2 or 3 years, though, there's been sort of a change of thinking at NSF in the sense that there are these workshops. There's also a call out for planning grants for, you and I had been talking about that by email. Maybe if you could find that solicitation and put that in for infrastructure for, you know, maintaining data sets and I think helping to provide that longitudinal capability. I mean, it's true for traditional merit review. If you just sort of send things in, normally people are, you know, okay, new shiny whatever, but there is that important, this is important for the community to enable research tools and data sets. And my sense is that there are now calls out for those kinds of activities, maybe coming from the workshops that you mentioned.
Oh, I think the workshop was material in giving some energy to NSF to put that solicitation out. And I applaud that. There's no doubt about it. Mm-hmm. I see Vasanta just posted, she beat me to posting the WAMBIR report. Thank you, Vasanta. All right.
Okay, great. So I'm gonna unshare my video now and just see if we have any questions from the chat specifically about this. Otherwise, I think we'll move into the next section. Okay, mostly, okay, there is a question. If anybody wants to handle this, are there any data sets available from dataset switches? I'll ask my 2 colleagues from Google in particular if they know about it. I know there are a couple of workload data sets, but I don't think from within the switches. Anybody know of anything?
Yeah, I think the first thing that comes to mind was I'm getting echo. Like around 2010, I think Theo Benson made some traffic from Microsoft available. I want to say Manya Gobadi made some of the optical data public, but I mean, it's not necessarily switches specifically.
Okay, maybe
so I recommend people to read the article that we published in CCR as Google that explain why there is no switch dataset available from Google, okay? But, you know, if you want one, I encourage you to harass us at Google until we make it available, because my personal position is that you guys, academic, are the one moving the needle in this area. I remember the springtime, and Sue was there. I mean, I remember Spring didn't want to share any data set. Okay, it was like, no, everything's secret, everything is competitive, we cannot share. And then came Rocket Fuel. And then Rocket Fuel published terrible topologies of Google, AT&T, and everyone. And then Sprint and AT&T realized that, oh, I mean, academic can do it, so let's give them. And then they give a little bit more all the time. So I think you guys have the power to make things change. And if you need something, you need to come to us. And if I have many requests, I can start working inside to give you the data or to make something available. Okay? And that my deepest wish is to help you and provide those data. But it's complicated, and the article explains well why it is complicated. Okay?
Yeah, so I think that comment actually is a really nice segue into the second part. So why don't we move on to the second part? And Phillipa, maybe you could, you talked about the optical network data set. Maybe if you could post that into the Slack channel afterwards. But you know, what Christophe was just mentioning, the Google article, for example, does go into details about or some of the rationale behind, you know, proprietary data from companies. And as an academic, I always remember thinking, oh, you know, why don't companies just make this data available because the research will benefit them and all those kinds of things. So, you know, one of the challenges we face is that making data public when you're in when you're in industry, it's in some cases the family jewels, and certainly in some cases proprietary. So that's just one of the challenges. So
Jim, should we finish the roundtable? We didn't.
I mean, finish the roundtable in terms of
the panelists. Remember, we were asking each panelist to tell us what problem they want to see solved.
Yes, that's what we want. That's what we want to do now.
Okay, sorry.
So Christophe, can you mute your microphone when you're not talking? Because I think there's an echo through your audio. Okay. So I think what we want to do next, just to sort of kick off the discussion about some of the challenges, is ask each of our 6 panelists here in a couple of minutes, just if they want to pick a particular challenge that they think is particularly vexing, particularly important, something looking forward into the future that's particularly important to do. And why don't we just do that alphabetically? So Dave, I'm going to turn things over to you first and just get your thoughts on challenges looking forward, opportunities, those kinds of things.
Step 1, unmute. I don't know how long a rant you want right now. Let me just tee up a whole bunch of issues. A lot of the work I've been doing recently has to do with internet security. I've also been working with some of the MLab data. I'm sure that Phillipa can talk about that. But in the security space, where we look at things like BGP hijacks or abuse of the DNS system, there are really 2 problems we have in that space. And one of them is to understand what the attackers are doing, but in some sense, attackers are adaptable. So what you're really trying to say is, okay, how are the ways we could change the system so that you make it harder for the attackers to adapt? And in order to do that, you need models of how the network is structured, and you need models of how benign behavior is going on. So I've been doing a lot of modeling of how the internet's glued together out of its parts to understand, well, where could an attacker be? And if they launch a hijack from a certain place, what's the scope of impact and so forth? One of the data sets I've been working with in that space is KAIST AS rank, which they derive from the routing data. So it's only as good as the routing data you get, but they try to infer who's connected to whom and what the relationship is, so you can build maps and you can say, well, this message would probably propagate like that. But there are a couple other data sets I'd love to have in that space. It's clear that the behavior of most users on the internet is becoming more local. When you model where most users go, they don't go very far in the internet. I modeled my own behavior because that's not a privacy violation. And, you know, like something 50% of the IP addresses I go to, I'm a Comcast customer, 50% of the IP addresses I go to are on machines that are directly attached to Comcast. They're mostly cloud, you know, Amazon and Google and so forth. And most of the ones that actually leave only jump 1 hop into level 3, and then they hit another Amazon cache. Okay, so we're not going very far. And that actually affects, for example, questions of how successful a hijack can be, because it's hard to hijack a path that's only one path, it's only one AS long. So I'd love to see more data about what people are doing. And the problem is that raises terrible privacy concerns. I'll give you another example of a place where I have a real privacy problem. When you look at some of the DNS TLDs that are being abused, there are still legitimate names in those TLDs. And so the question is, well, let's say somebody comes up with a draconian decision that we're just going to block all access to this TLD because there's nothing in it but garbage. How much collateral damage would there be? In order to do that, you need to know, well, you know, for a community such as all Comcast users or all people at MIT, how many people went to a legitimate domain name in that space? Well, you could try to capture that data, but again, that's PII because it's got the IP addresses in it. And so there are a lot of issues associated with understanding how good people behave to try to understand how to distinguish it from the way bad people behave. I'll tell you the data I want that's the hardest to get. We can measure, well, sometimes it's hard to diagnose what exactly is a hijack, but you can come up and say, oh, it probably looks like a hijack, that looks like a hijack, that looks like a mistake, that looks like a leak, and so forth. But when you go talk to people, they say, yeah, but are any of them actually doing any harm? And you know, why should I fix, just because there are all kinds of attackers doing things out there doesn't actually mean any harm is arising. And yeah, there are a couple of theft of Bitcoin, and yeah, well, just let them go suffer. So maybe the problem's not worth fixing. And the question of how much harm is occurring is far removed from measurements we can make on the internet. But if you're going to ask ISPs to crank up their attention to BGP hijacks or crank up their attention to invalid path hijacks, for example, you got to be able to persuade them that it's worth doing. And we really struggle with the question of making the case about harms. And harm's not the same as an attack. I actually found some economic analysis that said attacks are so cheap on the internet that an attack yield of something like 0.1% or 0.01% is still profitable. So counting attacks tells you nothing. You know, the fact that there may be 2 million phishing sites out there tells you nothing. You know, the fact that Google throws away 99.9% of all spam tells you nothing. So it would be nice to know what normal people do. It would be nice to know how much harms are occurring. And I think I'll stop because that's a long rant. Jim, I think
I'm muted, right. I'm sure we're going to come back to some of those issues of privacy and maps and data informing models.
Oh, I want to come back to privacy because I have a challenge question there later, but just
okay,
hold that.
Great. So I'll make sure we come back to that. So Italo, I think you're next.
One of the things I wanted to discuss is related to what Dave was talking about. So I work a lot on internet measurements, and one of the things we do with these measurements is try to build models of the internet to understand how it works. But it's very hard to validate any and draw conclusions from the measurements because we lack ground truth and we lack visibility, and there are many confounding factors with these measurements. And I'm amazed that whenever we get to cooperate with industry and operators to get ground truth, we not only get a lot of confidence in our results and the conclusions we can draw, but we might even improve the methodology just because we get these confirmations on this worked and this didn't work. We get additional insights and then we end up improving the methodology. So designing ways of engaging industry and operators to collaborate with them is definitely one thing that would benefit the analysis that we do with the data that we collect. And related to, we also talked a little bit about incentives. So Dave was talking earlier about how do we fund long-lived longitudinal measurements. And we have these awards now for papers that make data sets public. I think this is great incentive for researchers. So it's one step forward. So we get a lot of data sets these days. But maybe we should think about how to incentivize researchers to make their data collection continuous so that we get this longitudinal data. So there's I can get extra points in my reports because I've made data sets public, but I still don't get any points for making longitudinal data sets available. It's just, if the incentives might be aligned with what we do so that we have a stronger drive to make data sets longitudinal. And we could also, this is kind of a wild thought, but think about how can we incentivize industry and operators to make data sets available. So we researchers get, conference awards, and what can we do to get data sets from industry? Maybe there's, some hall of fame that we can maybe have, I don't know, some, thing that we could do to get data sets from industry. So these are two things that I singled out to mention.
Great. I hope we come back to industry incentives. I'm not sure an award to a major multinational hyperscaler is going to carry a lot of weight when there's privacy or proprietary, but I'd love to have that discussion.
Right. It might be a little bit different incentives for different industry.
Right. Okay. Timur, I think you're next. We're going alphabetical.
All righty. So I'd like to draw people's attention to Hotnet's paper from last year towards a traffic map of the internet. Thomas Koch, a doctoral student of Ethan Katz-Bassett, is the first author, but there are large number of people on the paper from different institutions. And it really sets out a challenge that has captured my imagination of not just trying to create maps of the internet, but really figure out to weight that in terms of the clients and the data providers and how much traffic is passing between them and via which paths. And to do that using tools that are publicly available and that researchers can deploy and not just purely depend on industry to open up this sort of data. So that's kind of grand challenge that I thought was particularly compelling.
Mm-hmm. Right, and that speaks to what users, what Dave was saying earlier about what users are doing, and
absolutely.
Right.
Yeah.
Okay, great. Phillipa.
I just want to give another +1 to that Hotnets paper. I really enjoyed it. I think one challenge I'm thinking a lot about since joining MLab is, we talked about how much we like these longitudinal data sets, but the challenges that come up with them. So, the operating system your measurement code runs on changes over time. The versions of your code change over time. And I think, figuring out how we account for all of this when we are doing longitudinal data analysis. So for example, our throughput test, if you have, the wrong combination of operating system patches, suddenly your TCP receive window is your bottleneck. And trying to find ways to, identify these different things that impact results in unexpected ways and, noting as they change over time. So one thing I added to the datasets list under MLab is the data annotations repository. It's not everything it could be, but it's a start in terms of trying to annotate different events in our data. So I think it's, how do we annotate? How do we take annotations into account? And what does it mean to look at 10 years of data? Is it comparable? What can we really say about it?
Mm-hmm. Okay, great. Sue.
Hi. First, thanks very much for inviting me as the panelist. I think in the past 20 years, the measurement space, the measurement research space for public data traces actually has shrunk. Not that we work less, but because what we used to do has moved much into the commercialized. So all the trace routes we do, a lot of what we do, people buy commercialized services. That's why, everything we want to do, they provide commercial services. So a lot more work, a lot more measurement work is done, but we don't get access because of the commercial. Everybody's monitoring their services. So everybody's doing traceroutes, CDNs, Netflix monitor their own. Also, stop networks are running their own monitoring services, etc. So I think we need a strong industry incentive to donate their data on equal basis, so that they do not compromise the trade secret you call. And maybe we need something like WTO, World Trade Organization, where all the trade secrets are. I don't know how WTO deals with the trade secrets, but I think we need WTO for the internet measurement. Yeah.
So great. So Sue, both you and Italo have mentioned incentivizing industry. I think either Christophe or Phillipa mentioned there was a Google CCR paper, I think it was, maybe 2 years ago, that spoke to some of that. And maybe if somebody could cut and paste that into the chat. Personally, I found that a really interesting paper. One of the things that paper talks about is actually something that Dave brought up about the issue of models, and maybe, even if the data is proprietary, maybe there's abstractions of it, and that can be used. So models, or it could be used to parameterize models or something, that there's still some use to it, but that it's not the data set itself, Sue, that you were just, that you or Italo, it's not the absolute ground truth, but it's one step synthesized from there, and that might be of interest. I don't know. Anyway, that's another paper that I think is an interesting one to read. I'm not sure if colleagues from Google, Christophe, I think you and Phillipa, I don't remember if both of you were authors of that or not, but.
Yes, in fact, yeah. I just pasted the link. Yeah, and yeah, it's there. I have the CCR version, and Timur has the Google version. Thank you very much.
Okay. Phillipa?
Yeah, I just want to add, like we're talking about incentivizing industry to make data sets available, but I think it's worth thinking creatively about how industry and academia interact. So for example, maybe the answer isn't publish the data, but maybe the answer is having common data formats, common tools where someone could debug and prototype their analysis on a public data set and then hand their scripts to someone at a company that they collaborate with who could then run the analysis on data that maybe isn't completely public. So maybe there's kind of more creative ways we can work together.
So Dave, there was a comment in the chat to come back to the question of models. So you brought the issue of models up first. Maybe could you say a little bit more about, I think you were talking about, to understand it's not the data set itself, but the data set sort of informs what the models look like.
I don't know whether I have something to say in that space that's very general. I mean, I'll give you, KAIST occasionally draws a picture, which is just pure eye candy, which is this picture of the entire AS structure of the unit. It's this big circle, and it's sort of iconic picture, and you can't make any sense of it. It's just because it's got so much information in it. And but you might, for example, ask about the topology of the internet. What percentage of the ASs that are at the edge are multi-homed? What percentages of the ASs that are at the edge that we've associated with abusive hijacking are multi-homed? I think the multi-homing question is a really interesting one, because technically, if you read, for example, Aaron's rules about how to get an autonomous system number, you shouldn't ask them for an autonomous system number unless you're actually multi-homed. But I've found chains of ASs, all of which appear to have one customer, which I don't know, are they just constructing paths out of the computer sitting on their table? Why do they get all those AS numbers? How many people who are multi-homed to a tier 1 and a tier 2 and something? So it's possible that you could come up with some models like that. I'd love to know, as I was talking about my own behavior and how far my packets go before they reach, in most cases, the cloud. It would be really interesting to know if I asked that same question from, say, Brazil or South Africa, what would it look like? How far do you go? And does that mean you're more amenable or more susceptible to hijacking? So I don't think you need to know exact topologies to know this, but these are the kind of things that, but to build a model, as you say, all models are wrong, some are useful. Several people have said that to me in the last week. You know, you sort of have to understand what question you're answering before you start to build a model to answer it.
Yeah. So maybe one thing again to come back to is this notion of contributory, or the ability to contribute your own end user traces, avoiding the PII issues because you're, you know, so think of it as citizen science, right? I want to be able to contribute this trace to a repository to maybe help answer those kinds of questions. So we could potentially come back to that. There's a number of questions that have been coming in, so I want to field a couple of questions that have come in and ask the panelists maybe for comment. So I'm going to just read one because Dave, I think it may touch on, well, it touches on a couple of issues that people brought up. So it says there's some reticence from industry because of corporate risk and competitive secrets. Might be worth flipping the proposition and finding a way, standardized way to query data in place, allowing corporations to preserve ownership, but answer queries. And I might add in some kind of privatized or privacy preserving, or I want to say differentially private, but I don't want to propose an answer way. And I don't know, do folks want to comment on that question?
I think the problem in that space is you're actually asking the corporate providers to do a great deal of work. You're asking them to put in place a system that layers some sort of query thing on top of their data. You're asking them to reason through the consequences of the queries that they've authorized. And you know, there are always people in the company who say, well, it's easier just to say no. Right. So you're actually upping. So I like this idea, but we need to find very cost-reducing ways of introducing this idea to companies so that they can say, look, this really won't be very burdensome. But I think, you know, there's always the question, as you push the challenge of processing the data back onto the person who owns the data, you've increased their cost. And you know, just handing out a data set is cheap. You know, we'll just download this 10 terabytes and then do whatever you want with, you know, that doesn't cost me much except my bandwidth.
Yeah, I guess something I've heard from within a couple of companies is that issue. It's not so much of the cost, but of the people power required to do it, right? And so the question is, well who's going to do it, right?
That's part of the cost, is right. Giving priority to the manpower, right? Absolutely, totally.
Right.
Yes.
I just want to chime in here. So I think, like, when we talk about querying remote data sets, I'm sure a few people's minds are going to differential privacy. Obviously, that would be nice. In an ideal world, we would have these systems. But more pragmatically, there are a few things I've seen along these lines that have worked. So like back in 2005, HP Labs and AT&T did papers where they were analyzing traces. And, you know, they passed back and forth Bro analysis scripts that could be run on traces at different places without actually sharing the data. More recently, and this is very recent and preliminary, you know, we've been working with congestion control folks at Google and researchers at CMU. And the model that we're going to try is have, you know, the academics prototype the analysis on packet captures that we have with MLab. And once the analysis is proved out, you know, an engineer at Google would then run it on some traces that might not be publicly available. You know, this is an active collaboration. It's something that, you know, both the Google folks and the external people are interested in. So there's kind of, it's mutually beneficial. It's not just like provide data and, you know, the people go and do things without you. It's really interactive.
Right. So bringing the computing and the question asking to the data rather than the data out there and ask any question you want, right?
But she said the critical point. When it matters to the company, they have a motivation to help. And you've got to find an argument that says to the company, this will benefit you as well as academia. That's really the secret.
Or you better make the data public because it will help you and academia. I mean, it could be a threat too, like in the case of Rocketfuel. I mean, they need to understand their benefits, which is not to propagate wrong or inaccurate information.
So going back to the industry incentive, maybe I'm going too far, but in the financial market, companies have to report their earnings every quarter, and they want to keep it secret, but they have to report for the public good, for the benefit of the public. The internet, all the service providers, they are interdependent. Routes go through each other's. So there is this interdependency that could be like a pressing roll call to subpoena data in a way, but just like a quarterly earnings report that you report, okay, Google made a lot of money, Google network is fast, but we only get to know every quarter so that people kind of feel good, but they have to, say something about their network because the networks are all interdependent. Just a thought.
I like that idea a lot. I wonder what the most important data would be that you would require of each network to share.
So I'll simply add, Sue, not at the detailed level that you're asking for, but the discussing what are the equivalent of nutrition labels, right? So that at maybe your point of purchase, when you buy a wireless plan, there's a fairly detailed description of what you actually get. It's not traces, it's more the performance. I think even that is pretty controversial, and what goes in there and how that's measured. I think there are actually a lot of pretty deep questions behind that. But I think even something simple like that is going to be pretty controversial.
Jim, I don't know whether you were talking about that as an abstract idea, but I assume everybody knows it is now the law. They must do that.
Right. So I guess there are requests. That's what I was talking about, Dave. Right. But
yeah, right. It's the law.
It's a law, but the law is such right now that I thought that the FCC is still soliciting input on what these should look like.
I think the reply to comments window is still open.
Right.
I forget. I filed a comment. I think the reply to comments is open, and we'll see what comes of it.
Yeah.
But it's going to be interesting.
Well, it's a step in the direction that Sue mentioned, but I think when you start thinking about it, it's a really, really hard question that maybe people interested in measurement are really interested in, but it's a hard question.
Yes.
Christophe, was there a question in the question and answer window also that we want to get to?
Yes, of course. There is a Q&A from Juan Sebastian Camargo Barraga. Why are the mobile network operator reluctant to share the radio access, radio network access data set? I mean, does someone has an answer, an experience in that domain? I don't.
So maybe just an observation. I could be wrong here. Actually, can you mute your mic, Christophe? Thanks. The mobile operators, I see fewer data sets from them than other sort of more internet backbone-y operators. And I'm not quite sure why. Maybe it's because I'm not quite sure. I won't even guess why it is, but I guess I would agree. I don't see a lot of traces out there. There are test beds where one can go. So I'd say the Powder test bed, for instance, in Utah. There are places where you can go and run some actually live experiments, but it's not data at scale, and it's not real users at scale.
Here in France, ARCEP, our telecoms regulator, requires mobile phone operators to provide pretty detailed coverage maps. It's not the same thing. And anybody can query it. It's an open data.
Mm-hmm. So there's a question that came in another question that came in, coming back to the issue of companies sharing data and models. I'll just read it if anybody wants to comment. If a company is not going to share the actual data, could they maybe share some statistical models that represent those data for research purposes? And I guess that's a little bit different than what Phillipa was talking about bringing your computations to the data. I think it's more, again, asking, might there be workloads, synthetic workload generators, for example, or benchmarks? Christophe.
So this is the same problem as the one Phillipa was mentioning. Okay, you need resource in the company to do that. So the easiest way is, yes, we can do that. Please come and visit Microsoft, Facebook, Google, and do the job right there and publish your model. I mean, that's the easiest way, and that's possible. Okay, I mean, all the big company, they are visiting professor, visiting researcher, and that's the best way to do it, because you cannot expect an employee of the company to do that, particularly in companies like Google, where we have no research in networking, okay, internally. So in that case, I mean, we would be happy to host someone interested in this kind of thing and just do the work. And now I cannot guarantee that the model will be authorized to be published, okay? You have no control on that. You have to go through the Google of, I mean, same at Facebook and Microsoft and Amazon, okay? This is not specific to us. I think you have a better chance to try to publish something and then Google will react. I can tell you that the SICOM paper on the sun storms that were supposed to impact the subsea cable performance. Have you seen this paper last year? There was a SICOM paper published by someone from UC Irvine, I think, and they were saying that there is a risk of sunstorms to impact I don't understand anything in optical networking. Okay, so and you know, immediately Google reacted, trying to prove that it was not true, because so that's another example of things that you can publish that can encourage us to put the real data or to publish some data to help you. I mean, of course, this code is not recorded, right?
Network measurement data, we look for, I mean, whatever we find in the network measurement data mostly has negative impact, right? We find attacks, we find anomalies, we find outliers. They are, right, they are say, oh, it operates well, the performance is excellent. People don't pay attention, and that doesn't translate to a positive impression of the operators. It only adds negative impression whenever we find something. So it's a great incentive, negative incentive for anybody any commercial operators to share data, right? I mean, do we have like a lower bound that this data, you know, this much trouble, it's okay to tell, sort of thing?
Yeah, it's a great question. We keep coming back to the question of incentives again and again and again. It's really pretty interesting, but it's true, right? And then the resources, right? Because the resources are going to be tied to the incentives. We've only got about 2 minutes left, and one of the things that we're really good at here at the Networking Channel is making sure, because everybody's schedules seem to be clocked to the hour. So I think we're going to we're going to need to wrap things up. I want to remind people that conversations like this and some additional postings that people had asked for can continue on the Slack channel. And I'm going to put up a slide again in just a second that will show you the Slack channel so you can take a look at that. And then I want to, but before I do that, maybe I want to thank all of the panelists. Christophe and I both want to thank our panelists for participating. It was a great discussion. And Sue, again, we're going to give you the Hero Award for showing up at 1 a.m. Korea time. And thank you so much, everybody, for the contributions and the contributions actually that came in through the chat and questions as well. I want to put up one slide just before we finish, just to do a little bit of advertising for the next networking channel event. So I'm going to share my screen here just so you know what's coming up next. Let me do this first. Share this. Again, this is just to remind people that the conversations can continue on through Slack. So I don't know, you can take a screenshot of that, email me, I'll be happy to send that. Actually, these slides will be posted so you can get it from there as well. So to continue the conversation on Slack, let me remind you again that this is the open Google Doc for the data sets. I noticed while we were in the earlier part of the first session that people were typing in there, so that hopefully that document will continue to grow. And then lastly, the next event that Matt Cesar from the University of Illinois is organizing is on programmability with P4. He and Nate Foster from Cornell University are the prime organizers of this, and they're going to have a fireside chat with Jen Rexford and Nick McEwen to talk about P4, and then they're going to have 3 researchers talking about specific things that they're doing with P4. So I think that'll be great. Today's session was great. Thanks again to all of the panelists for all the work done in putting this together, and hope to see everybody again in 2 weeks, same time. Bye-bye.